Okay. Homework number 5 is going to be due on Wednesday of next week. If you look at the schedule, it originally said that it was due on Tuesday, but I'd like to give you one extra day in case there are questions that come up related to the external rate of return. So one extra day for that. It'll be due at 4 o'clock on Wednesday, the 1st of March. Today we're going to talk about external rate of return. And just to remind you, internal rate of return has the assumption that the money that you're getting from a project is reinvested into either that same project or a project that is yielding the same rate of return. So IRR, the internal there, is talking about what happens to the profits. And so since it's been a while since we talked about internal rate of return, let's just refresh our memory with this example. Let's solve this example on Excel. And what you're going to see is it's very different from the external rate of return, which we're going to be working on today a little bit later. So for this, if we've got new equipment that costs $345,000 now and $22,000 per year for the next 6 years, at the end of 6 years the equipment is sold. During each of the 6 years it will generate $120,000 in new revenue. Okay, so let's kind of break that down on the whiteboard, put together a cash flow diagram. We've got an initial acquisition cost, a purchase price at the present of $345,000. And each year we have to pay $22,000. That's probably operations, calibration, maintenance, and so on. So 1, 2, 3, 4, 5, 6 of those. So it's an annual series with an outflow of $22,000 each year. And then it is going to be sold at the end of 6 years for $115,000. But before then, we get $120,000 in new revenue each year. So this annual series is $120,000. And then there's the single lump sum F for the salvage value, the sale of $115,000. Okay, so find the internal rate of return. We'll just break this down on here. We have to have the year, amount, and PV of amount. The internal rate of return is what is the interest rate that makes the sum of the inflows and outflows equal to 0. So it's going to be an iterative process that we follow to determine I. And of course, we'll use the IRR function later, but it's important to know how to apply the calculation process even without using the built-in function. So what we will put in is the net amount. So negative $345,000. And then the net amount here is $120,000 positive minus $22,000. So each year, well, that can't be right. 120, I'm missing a 0. That's more like it. Yeah, so $98,000 in net each year. But then in the 6th year, there's also the revenue of $115,000 from the sale of the equipment. So those are the amounts. And now we want to find the present value each year for some interest rate. We don't know what the internal rate of return is, so let's start with a guess of 1%. And we're going to be constantly changing that later. But for now, just starting with a guess, PV of this interest rate, anchoring the reference there so that we can drag the formula down. So we have to have those dollar signs. Here, N will be the year that we're in since it's annual periods and we're taking it to the present. Double comma because we want to skip over the PMT. We want the amount that we put in to go into the field where it is considering it as a future value. So minus of this amount, because each one of these rows represents just some isolated future value amount, which is being discounted to the present. So if I translate that to currency and drag it down, you'll find the present value, and then we want to have the total. So it'll be the sum of all of these. And now we're looking for what is the interest rate that makes the sum of the inflows and the outflows equal. So right now it's positive, which means that there's more inflow than outflow if you're discounting the future amounts only at 1% per year. But as you increase the interest rate, what it's doing is that these amounts in the future are becoming progressively less valuable in terms of their present value. As you increase the interest rate, what you're doing is you're discounting the revenue at a greater and greater rate. So rather than doing it manually, of course, we can use the goal-seek function to say we want to set the total to 0 by changing the interest rate. Okay. And what it finds is that this cash flow diagram, the money that we're getting over time, yields a 22.02% rate of return, as long as we can reinvest the earnings back into the same project or something else that's also earning 22%. So this assumes compound interest. So every year when we're getting $120,000, and of course we're paying out the $22,000, but this $98,000 in net revenue, for this to actually be the rate of return of your project, you have to put the $98,000 that you get into an account that offers 22% return. If you don't have a bank account that yields 22% return, and if you have to take this $98,000 and put it somewhere else, then your overall comprehensive rate of return won't be 22%. It will be some kind of a weighted average between the rate of return of the revenue being generated and the rate of return of where you're putting the profits and where they are compounding over time. So that's what we're going to be doing today with external rate of return. Is we're going to break away from this assumption that all of these amounts over time are being reinvested into the thing. Here it didn't even really tell us what it was, new equipment. So you may not need new equipment anymore that is like another piece of the same thing. So by the way, that was the manual way to do it. How do we calculate the IRR? Just using the function equals IRR, and then you use the amounts, not the present value of the amounts, just the range of data, and it calculates it for you automatically. It does the same thing that we just did. So the question posed here is, if your MAR is 20%, should the equipment be purchased? If your minimum attractive rate of return is 20%, then yes, you should purchase the equipment because it has a yield of 22%. We use the internal rate of return for initial screening. We wouldn't use the internal rate of return for selecting an alternative if there's multiple alternatives. We'll come back to that, and we'll do an illustration on why we can't use the internal rate of return to select alternatives in class. I think next week I'll do a proof that shows you that just because a certain project has the highest interest rate doesn't mean that it's the most profitable overall. But remember, the rule is the application of internal rate of return is you compare the internal rate of return to the MAR, and then that tells you whether a project is potentially suitable. Okay, any questions about the example?
So if the IRR is greater than the MAR, then the equipment should be purchased?
Correct.
Okay.
Yep. All right.
What is the same?
If it's the same, then purchase the equipment, because MARR, minimum acceptable rate of return. So if 20% is acceptable, then we go ahead. So the IRR should be greater than or equal to the MAR. Okay. This is the most valuable painting in the world. Actually, that may not be true. How to put it? It is the painting that fetched the highest amount at auction. I suppose that probably the Mona Lisa is more valuable, but nobody knows what its actual value is because it hasn't been auctioned. So maybe it's priceless, right? But this is the piece of art that we know the price for. It was sold in 2017 for $450 million. And it is a painting thought to be made by Leonardo da Vinci. And with emphasis on thought, because nobody is actually sure if it was painted by Leonardo da Vinci. This painting has a really interesting history. It didn't always look this good. Back in 2005, it was sold for $1,175, the same painting. But it was in really bad shape. This is what it looked like when it was purchased in 2005. It was down in New Orleans. I think it was a lawyer living in New Orleans, had this torn up, what was thought to be a copy of a well-known original painting, but everybody thought that the original had been lost. You know, back in the 1500s, lots of copies of this painting had been made, but everyone assumed that the original was lost. But after this was purchased in 2005 for about $1,000, it was sent to an academic art restorer who took x-rays and looked at it through like infrared imaging systems and used all sorts of techniques to notice that there was actually layers of paint behind it. It had been painted on top of it, and so they removed all of the kind of like enhancements that had been added and tried to take it just to the base layer, and then where stuff had been lost, it was added by the restorer. But yeah, it was purchased by a middleman for Mohammed bin Salman for $450 million back in 2017, and nobody knows where it is right now. When it was originally purchased, they had said that it was maybe going to be displayed at an art museum in Abu Dhabi, but there have been some people who've speculated that it's actually on a yacht somewhere, floating around, a $450 million painting on a yacht. So it's
Mohammed bin Salman, that dictator.
Yeah.
You know how sick I would be if you sold something for $1,000 and you were sitting on $450 million and you didn't even know.
Yeah. Well, yeah, a lot of people are surprised that it sold for that much because there's no way to know if that's really a Leonardo da Vinci painting. You know, even if it does date back to the 1500s, a lot of people suspect that it might have just been like his helpers who did most of the painting. That, you know, like maybe all he did was a little bit of a sketch, or, you know, like when there was an artist, there was like a group of assistants that did a lot of his work for him. And so it's just, you know, it's an interesting story, but think about the rate of return from 2005 to 2017. What's the rate of return on that? We just calculated, let's do another cash flow diagram here. It's going to be an odd cash flow diagram because what you do is here in 2005, you pay $1,175, okay, 2006, 2007, 8, 9, 10, 11, 12, 13, 14, 15, 2017, right? So 2017, you get $450 million. Now, it was actually sold twice in between those two different dates. It was sold, I think, for like $100 million in 2012 and then $200 million in 2015 or something. But between 2005 and 2017 is 12 years. And so N equals 12, P equals 1175, F equals $450 million. So the rate of return there, if we have the rate function equals rate, okay, NPER, the number of periods, 12. Okay, and it's asking what's the payment. No, we're not doing a payment. I'll skip over that. PV, okay, our present value is negative 1175. FV, our future value is 450 million. Okay. Okay, it's having a little trouble with this one. I don't know why. Maybe it's just it thinks that I've given it a mistake or something. I don't know. I don't know why.
300,000 a year, 400,000. More than that. 600,000.
That's wild.
Well, maybe I'm not using the rate function correctly. Let's do it the old-fashioned way. A year, amount, and then PV of amount. Okay, so 2005, 6, 7. Actually, I'm going to call it, year 0 is 2005. Okay, so same as what we just did through year 12. Okay, so then the amount here was negative 1175. And the amount here is 450 million. Okay, and we're going to have to use our iteration to find the internal rate of return because we don't know what that rate of return is. It's using scientific notation because it's so much money. Equals PV of at the rate. Oh, I need to anchor that. N. Okay. Amount. Okay, now what we're looking for is we're looking for the total to be 0. So we have to use goal seek to make it so that that total is 0. So is it 10% rate of return? No. 90% rate of return? No. Okay, let's see if goal seek will work here. So our goal is for the total to be 0 by changing the interest rate. And okay, so that is, as a percentage, that's 192% per year. So that's a little bit better than the stock market because they say over the long term the stock market is about 7 to 12% per year, depending on what period of time you look at. So like the compound interest is 192% per year. So it's like they put in 1,075. The very next year it would be worth 192% of that. So what is 1.92 of 1175? So it's like 2256, 2256, and then the next year 1.92. 4331, and it just keeps getting bigger and bigger and bigger until it's $450 million. Now, the only problem, that's a great investment. I'm sure that the people who bought it in New Orleans that year are just pleased at their investment. They didn't get the 450 million, but I think they did get more than 100 million. So they also did okay. They're never going to do that again. That was a once-in-a-lifetime opportunity. There isn't any more unknown Leonardo da Vinci paintings that a Saudi prince wants to buy and put on his yacht. So since it's a once-in-a-lifetime thing, we can't really calculate internal rate of return because remember, internal rate of return assumes that the money that's being generated is reinvested into the same project. And so you can't do that. And so really the question is, what's the rate of return on the project if the earnings that you're making over time are reinvested somewhere else? and not internal to the same project. So internal rate of return we can use to compare against the MAR and know whether a project is acceptable. So we'd use the IRR for initial screening when reinvestment is available. So a savings account, you can reinvest your earnings. A mutual fund, instead of sending you your earnings in a mutual fund, they're more than happy to use your earnings, your dividends, to just purchase more shares. And so that's reinvestment. But because of that assumption that the inflows are being reinvested into the project, it doesn't apply to a lot of situations like if you've bought a business and you're getting cash over time, like the example that we worked in Excel a few minutes ago, or this situation, it's not reinvestable. And so external rate of return is used when the revenue can't be reinvested back into the project. So if you bought a rare painting and then you sell it, you have to buy something else with the profits. You can't reinvest it into the same painting. Okay, so the overall idea of the external rate of return is that outside reinvestment rate, the external reinvestment interest rate, can be considered. And so if the idea is that you're getting revenue every year and you put that money into a savings account, then the savings account would be the external reinvestment interest rate. So it's where you put the money that's generated. And our method for finding the external rate of return, for calculating it, is that you have to find out the net cash outflows and discount them at the unknown, for now, the external reinvestment rate is always given. So you discount the outflows to times 0 at the external reinvestment rate, and the inflows are compounded to the future at that same external reinvestment rate. And then the external rate of return is the interest rate that establishes an equivalence between the inflows and the outflows. So maybe that explanation doesn't make sense. I have a visual representation of the process, but you know how there's just the IRR function in Excel makes it really easy? There isn't an ERR function in Excel. So like on this one, you could either do it the long way or you can just type IRR. There's no such thing as equals ERR. At least I don't think so. Yeah, there's not. There's no external rate of return function. So we're going to have to know this process on our own. And what it is that you take all of the outflows, so that's the money that you pay, take it to the present. So see these 1, 2, 3 arrows? All of that amount you take to times 0, and you're using the external reinvestment rate. And then all of the inflows, so these ones on top of the diagram, those inflows get compounded to the future, and that's what this arrow is. So now you've kind of consolidated your cash flow diagram into one inflow and one outflow. And then you use some unknown external rate of return. You discount the inflows to the present using that ERR, and then you keep changing it until the magnitude of the two are equal, till the outflows and the inflows added together are 0. Okay, so it is defined as the interest rate that makes the present worth of the future revenues equal to the present worth of the expenses. Here's a formula that says the same thing. So here we've got expenses and revenues. So E is expenses, R is revenues. And so the expenses are all taken to the present. The revenues are all taken to the future. And when you're taking the revenues to the future, you're using the external reinvestment rate. But then when you're relating together the outflows and inflows, you're using the unknown, I prime, the unknown external rate of return. Okay, so this is the example that we're going to use to apply the process. We're going to find the external rate of return for this investment, where you have to pay $11,500 at time 0. There's these other times that you have some outflows. And so remember, our process is we're going to take all of these outflows to time 0, all of the inflows to year 13, and if there's any year that has both, we should only have the net. So in year 5 and year 11, we need to just have the net amount. And so when we're discounting the outflows to time 0 and the inflows to year 13, we're using the external reinvestment rate. But then when we're taking that lump sum of the revenues from year 13 to time 0, we're going to be iterating using some unknown interest rate until we get the sum of the inflows and the outflows at time 0 equal to 0. Okay, so go to that template file that I put onto Blackboard, download a copy of that, all right. So we're going to have to adapt this because this cash flow diagram goes for 13 years. So we've got some more rows to add. But the column headers are the right way. Okay, so just insert a couple of extra years. We're at 10, we need it through 13. Okay, so we've got through year 13, and then this column isn't going to be years until year 7. It's going to be years until year 13, because all of the inflows have to be compounded to year 13. Now, in the problem statement, oh, sorry guys, I have the notes for you, but I didn't give them to you. There you go. Extra set there. All right, so the external reinvestment rate is 5.5%. Okay, so here, 0.055 is our external reinvestment rate. That is, when we get in year 1, for example, this revenue of $6,500, we're putting it into an account that makes 5.5%. That's the best we can do. We want to know the overall rate of return, including the rate of return that these revenues are generated, but then also taking into account the rate of return of where we're compounding the interest. You know, so when you get revenue and you put money in the bank, you're going to get some, not only the profits from the investment itself, but then the profits from the interest of where you put the money. Okay, so this, we're going to do the reverse time column, so it's going to be 13 minus whatever n is. In other words, counting down from 13 back to 0. Okay, now we'll put the amount in each year, and I guess I'll just differentiate between the outflow and the inflow. Maybe I just won't even bother putting this column in, but like for example, the outflow Now, since it's called outflow, I know that that's a minus sign. So the word outflow means that I don't have to put the minus in front of it. So 11,500 is the outflow in year 0. Now, year 5, it's not going to be an outflow because the net amount is positive. So I've got one in year 9 is the only other outflow that I'm going to have to factor in. So it's 5,400. And then all the rest of them, there's no outflow. So we'll just fill it in with 0. Okay, now our inflows is 6,500. Through year 5, though, it's not 6,500. It is 2,500. Okay, then back to 6,500 and 9,200. Okay, nothing in year 8. There's no inflow in year 9. Year 10 is nothing. Okay, year 11, it's going to be 6,700. And then 7,800, 7,800. Okay. So everybody got the same thing in your spreadsheet? Okay, so now we want to find the PV of the outflow. Okay, so let's use the PV function for that. Equals PV. Now it's asking for the rate. We're going to discount it at I sub I. That's the external reinvestment rate. So refer to this external reinvestment rate and anchor the reference. NPER is the number of years. Skip over the payment field because we're treating each one of these amounts that go into the PV function as a single isolated future value. So for the future value, put the minus of the outflow. So 11,500 at time 0 is worth 11,500. When we carry that through, then we'll see the 5,400 in year 9, when discounted at 5.5%, is only worth 33.35 at time 0. Okay, so we've got the sum. Now let's add up all of the outflows. So 14,835. Okay, next, find the future value of the inflows. Okay, so equals FV, and we're using the external reinvestment rate there, so anchor the reference so we can drag the formula down. Now, NPER, we're not just using the years, we're using the reverse time column because we want to compound into the future. For example, any amount that's far away from year 13 is going to have a higher number of compounding periods. Skip over the payment field, and then the amount that we put in minus of the inflow. Okay. We drag that formula down.
Shouldn't be 0 in years 0.
Oh, yes, it should. Thank you for noticing that. Yeah, there's no inflow at year 0. Good catch. Other mistakes?
Minus 0.1 points.
Yeah, take at the end of semester evaluation. Lecture 13 had the wrong amount in year 0. Okay, so now we need to add up these. So equals sum. Add it all up. Okay. So what we're looking for now is we want, this is just a big lump sum. We're basically taking these amounts to one lump sum present value and one lump sum future value. So this is at time 0 and this is at time 13. We want to know what is the interest rate that makes, if you take this lump sum future amount to the present, what is the interest rate that makes it equal to 14,835? So let's just put in a goal seek, like a placeholder for now, maybe 1% as a starting point. And now here in this last cell, what we're doing is we're discounting the sum of the future values to the present at this interest rate. So equals PV at the external rate of return, and the number of periods is 13 years, so I'm just typing in 13 there. And the amount that goes in, it's not a recurring payment. It's not like there's 13 payments of 95,000. That's a lump sum at year 13. So we skip over the PMT and we say minus of this amount in the future value field. Okay. So 83,615. We want to know what is the interest rate that makes that equal to this. So let me pause for a second, have you do that. Do goal seek, and the objective is keep changing the external rate of return until this amount equals 14,835. Where if we go to the diagram here, so right now we've got one big future value and one big present value. That's the stage that we're at here. Here's our big lump sum future value. This is an amount in year 13. This is an amount at year 0. And if we discount the future amount to times 0 at the guess interest rate, this is the result. And so our objective is keep changing the external rate of return, I prime, until this amount equals 14,835 and 20 cents. Okay, so 2% gets us a little closer. 3% gets us closer, 4% gets us closer, and then it's at this point that I decide I'll use the goal seek, and now my objective is set that to 14,835.2 by changing the interest rate. Okay, so it should be 15.37%. They have it? Does everybody understand? Feel comfortable? You shouldn't feel comfortable because you're going to have to do this from scratch. So, like, think about if you didn't have a template file, you didn't have this in front of you, and all you had was the problem statement. So my challenge to you is go home tonight and just from a blank workbook, repeat this exercise starting from scratch. And so remember, you could draw a little diagram of what you're doing is like your objective is you want to have a big lump sum at the present of the outflows, a big lump sum at the future of the inflows, and you've used the external reinvestment rate to get those, and then you're going to be taking that lump sum back to the future, back to the present at the external rate of return. And you're going to keep changing it around until these two arrows are the same length, until the inflow and the outflow are equal. So give yourself some practice. I think in the homework assignment, there is an external rate of return. Oh, I hope it's not the same exact. Oh, yeah, it's not. Okay. I'd feel bad if I gave you the same homework as the example that we just worked. So there absolutely will be one of these on an exam. Absolutely, 100% guaranteed. You're going to have one of these questions, whether it's the midterm or the final or maybe both. You will have an external rate of return problem. So you'll need to be able to do it from scratch. And so give yourself the reps. You do the reps and you'll remember it. That's all for today. Remember that the homework assignment which I've just given you, you've got until Wednesday of next week to solve that one. And so I've got some exams to grade in another class, but then once I do that, I'm going to start going through your projects. I hope to take a look at some of those over the weekend. So I'll be scoring them and giving the grades soon.
So the external reinvestment rate,
Mhm.
that seems very similar to like the internal rate of return. Because internally you're reinvesting into the project, right?
The external reinvestment rate is where you put the money that's separate from the opportunity that was generating the revenue in the first place.
So like putting it into like a retirement account?
Savings account, retirement account.
And that's why you have a separate column for outflows and inflows, right?
Yeah, let's say that you bought a rental property, and you know, every few years you have to put in new carpet. Every once in a while you repaint. So you know, you have a big expense one at the present when you buy it, and occasional expenses over time, and then you're going to have a lot of revenue over time. And then what if you sold that property? So you'd have a cash flow diagram with both inflows and outflows. But every month when you get rent, you're not buying another apartment with it. You're putting it in some other bank account. So that's why to calculate the external rate of return, then you'd use the external reinvestment rate for the...
So then why would you discount your outflows at the same interest rate? Because that money's going out, so shouldn't that be like a rate of inflation or something? Because it's not going into that account. So the account's generating the profit with
Mhm.
that interest rate.
Mhm.
The money going out, why is it discounted? Are we just like making that assumption that the money's going to appreciate at the same time that that account is going to appreciate? I don't know if that question makes sense.
Yeah. Well, I guess the reason why is because it's the external reinvestment rate that you could have gone there to get money as well as to put money. You know, like if you think about the revenue that you're getting from your rental property, it's that same external account that you go to, like, to buy the paint for it. And so outflows are affected by that interest rate in the same way that inflows are.
Okay, so think of it as like one holistic account.
Yeah.
I might be getting a little in the weeds here, I don't know.
Well, I'm glad that you're interested. All right. I'll see you on Tuesday.